Solar batteries, also known as solar energy storage systems, are used to store energy produced by solar panels during periods of sunlight for use during periods of low or no sunlight. These batteries are typically rechargeable and can be used to power a variety of devices, from small appliances to entire homes or businesses. The main characteristics and parameters of solar batteries include operating voltage. The operating voltage of a solar battery refers to the range of electrical potential difference between the positive and negative terminals of the battery at which it can effectively function. It is typically specified by the manufacturer and depends on the design of the battery. For solar batteries, the operating voltage usually falls within the range of 12 volt to 48 volt. The specific voltage required for a solar battery depends on the overall system design and the power requirements of the connected devices or appliances. Charging voltage. Charging voltage is the voltage level at which the battery is charged by the solar panels or external charging source. It is important to provide the battery with the appropriate charging voltage to ensure efficient and safe charging. The charging voltage may vary depending on the type and chemistry of the battery. Manufacturers provide recommended charging voltage ranges for specific battery models to ensure optimal charging performance and longevity. Capacity. Capacity can be expressed in ampere hours, for certain battery chemistries, such as lead-acid batteries. Ampere hour is a unit of electrical charge that represents the amount of current a battery can deliver over a specific period. Energy, in the context of solar batteries, refers to the stored electrical power that can be used when needed. It is measured in kilowatt-hours. The energy stored in a solar battery is directly proportional to its capacity. A battery with higher capacity can store more energy, allowing for extended periods of power supply during nighttime or cloudy days. The stored energy can be utilized to power various devices, from small appliances to entire homes or businesses, depending on the capacity of the battery. Continuous charge current. The continuous charge current refers to the maximum current that can be supplied to the battery during the charging process. It is typically expressed in amperes and is an important parameter to consider when selecting a solar battery. The continuous charge current determines how quickly the battery can be charged. Higher charge currents result in faster charging times. However, it is crucial to ensure that the charging source, such as solar panels or a charge controller, is capable of delivering the required current without compromising safety or battery performance. Continuous discharge current. The continuous discharge current represents the maximum current that the battery can deliver to power connected devices or appliances during discharge. It is expressed in amperes. The continuous discharge current rating is important for determining the battery's ability to meet the power demands of the load. A higher continuous discharge current allows for powering devices with higher power requirements simultaneously or running high-power devices for an extended period. It is important to match the battery's discharge current with the power requirements of the connected load to ensure efficient operation. Temperature range. The temperature range within which the battery can operate effectively without damaging the cells. High temperature can cause faster battery degradation and low temperature can reduce battery performance. Battery chemistry. There are different types of battery chemistries, such as lithium-ion, lead-acid, and nickel-cadmium, with each having different characteristics in terms of cost, capacity, lifespan, safety, and environmental impact. Lithium-ion batteries are becoming more popular for solar applications due to their high energy density and long cycle life. When selecting a solar battery, it's important to consider these characteristics and parameters in relation to the specific needs and requirements of the solar energy system. A battery with a high capacity, cycle life, and efficiency may be preferable for a system that requires a lot of energy storage, while a battery with a high power output and fast charging time may be preferable for a system that requires quick bursts of energy. Overall, solar batteries play an important role in maximizing the use of solar energy and reducing reliance on fossil fuels. Understanding their characteristics and parameters is essential for designing and implementing effective solar energy systems. At the end of this video, Let me ask you, what are your thoughts on the role of solar batteries in maximizing the use of solar energy and reducing reliance on fossil fuels?